they're like, this isn't useful. And they go to another one. You're like, how did you figure out that wasn't useful in 2 seconds? Like, how can you know that it wasn't useful? And it's just a lot of practice. We do in the wiki have a bunch of tricks and tips that we use to Google effectively. And I'll just drop that link right now. So check that thing out. And it has a bunch of tips and tricks that we use for getting good programming answers when Googling. Did I freeze? Am I still frozen? It's weird, I can see Slack. Oh, good. What about now? What about now? What about now? No audio? I've got half audio, I've got half video. Is it lagging because Zoom just got sued? Yeah, I just read it in the news this morning, a lawsuit about something about corporate lies or something. I don't know. I got enough stuff on my plate. Zoom can deal with that as long as they keep working for me. Tell me if it goes out again. If it gets too weird today, we can go do a Twitch backup, which I barely ever use, so it's probably going to be nightmarish. I'm scared to death that I'm frozen up again. Several people are typing. Wow, mixed reviews. Selling max headroom. I'll take a good max headroom reference any day. And if you're not familiar with max headroom, then you should definitely go look that up. All right. I do a quick poll. Better now. Yes, no, yes, no. I'm delivering audio and video, and it looks like it's going poorly. The background probably doesn't do much, but we can try it. It's a lot more boring without this. Let me do this. Let me share the screen. Let's see if that makes everything better. Let's see, on the right thing. This will lower all the bandwidth costs for me because this takes a lot less bandwidth. Then I'll close this thing. What about now? If it's, tell me if it's not working now. Who can't hear me? A little better. I'm going all the way. Stop the video. All right, gang. Let's try this for a while. And if it gets too bad, just tell me again. I've like killed all my bandwidth, so hopefully this fixes things. All right. Where were we? We were Googling effectively. That's what we were doing. And so check out that Wikipedia page I posted. Check out Max Headroom. And let's see. The other thing I want to talk about really briefly is iterables. Because these are really interesting. And we saw these a little bit, but I want to talk about it more generally. So we've seen loops like this, right? So this works. We can also do lists, and we can use for I in the list. What's important here is that this thing, after the word in, this is an iterable, we call it. That is something you can iterate over, and a lot of different things are iterables. So tuples are iterables. You can do this. You can iterate over that. You can open a file. That's an iterable. You can iterate over that. I think it iterates a line at a time with files. The thing is, the idea is lots of things are iterables. Range returns an iterable. A is an iterable in both these cases. The file that got returned by open, that's an iterable. So for is really flexible here. For will iterate over anything that is iterable, and a lot of things are. Even dictionaries are. You might be like, well, if I iterate over a dictionary, what's going to come back? I believe it's the keys. The keys come back when you iterate over a dictionary. So keep that in mind. The for loop, anything that's iterable, you can loop over. And it'll tell you if it's not. Right there, I tried to iterate over x, which is the value 12, and it told me right away that 12, the integer, is not iterable. Sorry, you can't iterate over that. So if there's something you feel you should be going through all the elements of, it's probably iterable. Lots of things in Python are. Does that make sense? No dark mode. Oh, I tried dark mode for a while, and it's weird. I've got a dark mode Vim. Anyway, iterables. Any questions on that, or is my internet connection gone? And I'm just talking to myself. Okay. Great. And the internet is fine. Iterables are fine. It's pretty awesome. I especially like being able to iterate over a file and get lines out of it. That's a neat thing to do. Getting individual lines out of a file with Node.js, at least I don't know of a clean way to do that that doesn't use callbacks. So here's 2 lines of printing out everything in a file. Was there, no, what can't you iterate over? Int, none. To answer this question, I'm gonna give kind of a visceral gut feel answer to it. In that, like, integers, if you just have a single integer, like, there's no collection to iterate over. So for something to be iterable, it has to be a collection of some sort. I use collection in a general sense there, not specifically referring to lists or dictionaries, but it has to be a group of things that you can go from one to the next through. So int is just a thing, just one thing. It's not a group of things. So you can't go from one thing to the next. But anything that's a group of things, now you can start thinking, okay, I can go from the first to the second to the third and go through all that stuff. For instance, a string is a group of things. So why not? Can we go through each of those things in the string? Yeah. So that would be the question I would ask. Is this a group of things? And if it is, we can probably iterate over it. If it isn't, like int or none, then we probably can't. So a file is considered an iterable string. I would say it's considered an iterable file. And so when they were putting this together, when they were building Python, they're like, is a file a collection of things? And they're like, well, yeah, it's a collection of lots of different things. Like it's a collection of characters, it's a collection of lines, it's a collection of paragraphs, it's a collection of blocks, or however you want to look at it. And the Python designers decided it's going to be a collection of lines, that this is the most useful way we can write this. We've decided that a file is a collection of lines. You can iterate from one line to the next line. And the reason, Ariana, the reason I'm staying away from thinking of the file as a string, even though you might be thinking, well, it's just a big collection of letters, right? Just like a string, is because some files have binary data in them that aren't just collections of letters. And so I'm abstracting that in my mind, and I'm thinking, okay, this is a file. It can be a text file, but it could also be a binary file. It could be anything. When you iterate over a binary file, I'm not even sure what happens. That would be a good question. What happens when you iterate over a binary file? I'll have to look that up later. Because binary files don't have lines in them. They're just raw data. I don't know. I've never tried. Good question, though. Yeah, you have to open the file in binary mode. This is opening it in read binary. But I don't know. I don't know what's going to happen when I try that. I'll try it later and let you know. Did anybody find anything else this project, the last 2 days, that was surprising or compelling, or that you really liked, or that you really hated? More opinions on the list comprehensions? Tuples. Still trying to figure out the calendar one. Yeah, calendar one is it's surprisingly nuanced. It's got a lot of little pieces. The final code is like 15, 20 lines long or something, but it's got a lot of little tiny pieces to it. Some list comprehension fans. Robin, did you like tuples or hate them? I'm assuming like. Yeah, Jocelyn, this is interesting because I haven't touched React in a long time, and when I was messing with it, it was still pretty object oriented. And now everybody's making this swing to functional, which I think is actually pretty cool. So now we're going to be talking about object oriented programming, which is, you might think, well, if we're switching to functional, like why would we learn this object oriented programming stuff? Object oriented programming as a paradigm is still huge in the world. So I'm pleased that everything's going function oriented there, but this is also a good thing to learn. Anything you learn that's different than what you know is totally worth it. Let's see, more descriptive code. Yeah, Michelangelo, some people say that there's no difference between pseudocode and Python, which is funny. See, Russ says there are times you write 4 codes you don't want to because you lack the experience to write the 3 you wanted to. That's fine. It's true. As I develop as a developer, as I become a better developer, I do this by reflecting on things I've done. And I was like, okay, I did that in 4 lines there. Not particularly pleased with that. Is there a better way? And as I reflect, I look back, decide if there is a better way, and then I can use that going forward. But that's been my entire programming life, has been writing code that was kind of bad, and then later figuring out how to make it better, and then later figuring out how to make that better, and later figuring out how to make that better. It just keeps going, and you iteratively get better at it. All right. The tuples versus tuples fight. I keep saying tuples, and I think everybody, the real one is tuples, but I'm not sure. So a real world example of when you'd use a tuple or a tuple. There are lots of cases where people build lists that are never going to change, and you don't want them to change. And so you can just kind of think of a tuple as a constant list. So if that's what you need, then go ahead and use that. Otherwise, use a list. That's the big question. Am I going to change this ever? Is anybody going to change this ever? The answer is probably not. Then a tuple is a great thing to use. I don't know why map and reduce are slow, but I'm sure it's been a discussion. Classes in Java a little better than Python classes, at least for them. All right. Definitely a different feeling beast. Object-oriented programming is really nice, great for gaming, back-end stuff. It is great for gaming. One of the reasons it's great for gaming is because when you're playing a game, it's actually full of objects, right? You're playing a 3D game in a world that's full of cars, it's full of NPCs, it's full of trees, it's full of all kinds of things. These are actual objects that have attributes and you can interact with. So object-oriented programming is great for that. It's great now, but when we get to algorithms, one of the reasons we choose Python is because the language doesn't get in the way very much. It's a pretty easy language to learn. And when we get to algorithms, we want to be thinking about algorithms, not like the minutia of the language. Let's see here. These are all excellent comments. Brandy, is that an English rule? Because if it's a rule about English, there might be exceptions to it. Just say it. Oh, the poor people who have to learn English as a second language. I never envied them. Let's see here. Katie has a good question here. Do you think we'd benefit from watching Algo's videos in our first language to get used to the topic? I'm going to say no, because here's why. And we'll talk more about this when we get to Algorithms Week. But remember Ooper, understand, plan, execute? When we get to Algorithms Week, 95% of your time is going to be spent in understand and plan. And that doesn't have anything to do with the language. So it's going to be thinking about how to solve these things conceptually and stepping away from Python or JavaScript or arrays or anything like that. And you're going to, instead of thinking about arrays, you're going to think, well, maybe I have a collection of items here. And how it's stored. Is it a list? Is it a dictionary? We can worry about that later. But I have this collection of items and I need to do something with it. Like I need to sort them or something. What are the steps I need to do that? With sorting, we're going to talk about imagining you have a bunch of blocks in front of you with numbers on them. And you have to come up with a very simple set of instructions to sort that collection of blocks. Like as if you were standing there. Forget about programs and computers. This is describing how to sort these blocks to another person. So that's where all the hard work comes in with Algorithms Week, and not so much with the language. And if you come up with a good plan, this is true everywhere, not just in Algorithms Week. If you come up with a good plan, then programming is just writing it down, and that's it. That's kind of the easy part. Which seems weird. Programming, writing it down has always been the hard part, but with Algorithms Week, planning is definitely the hard part. And as you progress as a developer, you'll kind of find that planning is always the hard part. We just tend to skip it. Like I said, lots of people like to skip planning, myself included. And so it seems like programming is the hard part because we've skipped planning and we've thrown it in with the programming and everything's a big jumble in there. But when we separate it out and we're like, oh wait, making the plan, this is tough. Doing the implementation is just writing the plan down. David has a very valid point there too. All right, let's see here. What time we got? We got a few more minutes here. So today's a big object-oriented programming day. And we're gonna, yesterday, if you got through the end of the project yesterday or the day before, there was some stuff in there about classes. And we haven't talked about classes yet. So you're like, probably like, why? Is there something about classes in the project when we haven't talked about this? But it's there for a reason, a couple of reasons. A lot of you have already seen classes in your previous language. So this is kind of like how Python does that. But also there's something to be said when you're learning to getting a quick intro to something the day before and then looking at it in more detail the next day. And I actually use this on my own when I'm not even in class. At the end of the day, when I'm working on some project, I will look at the stuff in that project for the next day. It'll be like the last 5 minutes of my day. Like, what am I doing tomorrow? I'm gonna do X and Y and Z. Here's my to-do list. These are the pieces I need that are gonna be difficult for me to implement that I still need to sort out. And I just kind of put that in my brain at the last minute. And then the next day, like your brain kind of chews on that stuff in the background, even if you're not consciously thinking about it. The next day, everything's a little more familiar. You get a quicker start on it all. So that's kind of the reasoning behind looking at some things before we talk about them. Plus, you think about problems in a different way before lecture than after lecture. And mixing up these different ways of thinking about the problems. One on your own, where you're like, what am I doing with this? And the other, where you're doing it saying, oh yeah, I remember Beej talked about this in lecture. These are kind of two different ways of learning, and mixing those up can keep things fresh in your brain. So, programming paradigms. I mentioned this word yesterday or the day before, and I think I defined it as a way of modeling a problem in software, which is a really vague description. But for me, it's kind of a way of thinking about the problem. How do I want to model this? So with the procedural programming paradigm, I think of the problem as a sequence of steps that have to occur, like a sequence of procedures. With functional programming, it's a little harder for me to describe in words, but I imagine this as a bunch of functions that get passed around that operate on other functions. A more mathematical way of thinking about the problem. And with object-oriented programming, I think about the problem as a collection of things that have information stored about them, with them, and have actions that can be performed on them. Now, all these paradigms can solve all problems. It's just some are easier than others. So with video games, when I say we have a video game world that's full of cars and people and trees and things like that, personally, I have an easier time thinking about those as objects than I do thinking about them as functions or thinking about the functionality between them as functions. My brain just thinks those are things that have attributes that can do things. And that's what object-oriented programming is all about. a different way of thinking of a problem. How we feel so far about that. I'm going to keep going, but oop for W. Yeah, sometimes. With the thing with oop and the abstraction, we'll talk about that in a little bit. I'll do some demos here, Brandy. So for me, learning a new programming paradigm is the hardest thing. I'd mentioned earlier learning Erlang where you couldn't change variables. Erlang is a very functional programming language, and I didn't know the functional programming paradigm. And I was having trouble learning that. If I'm doing another language in an existing paradigm I know, I'm pretty good with object-oriented programming. If you want me to jump from C++ to Python to JavaScript with its classes to Swift, which I'm sure has classes, I'm good with that. I'm like, I can take that programming paradigm, that way of thinking about problems so that I can solve them. I can take that and go to any object-oriented language and use it. Now, if I go into a language like C, which isn't particularly good with object-oriented programming, you can kind of fake it, but the language gets ugly fast. It's a bad way, it's a bad match, right? C is not good with object-oriented programming, and if I take that model and try to cram it into that language, it just looks bad. But most languages today, most modern languages are pretty good with it. Even the Go language, not really object-oriented, but the same concepts can still apply to the way they have things implemented. But for me, learning a new paradigm is the hardest thing. New languages in the same paradigm, pretty easy. New paradigm, whew. I don't want to branch too far off into Go, Doc. But there is a Go channel if you want to learn Go. Highest paid software developers program in Go. Really demand field and a pretty easy language to learn. Just got to think about things slightly differently with Go routines and channels and stuff. All right. So I've already talked about how we're going to think about things as collections of objects. I'm going to do some quick demos. Let's take a break. I'll do some quick demos after this just to kind of get used to the syntax and basic terminology. And then we will do a more comprehensive exercise where we'll take a specification and we'll try to figure out what objects exist within that specification. So somebody will write something in English and we'll try to take that English description and turn it into a model using objects of something that we can run as code. And there's a semi-straightforward way of doing this. One of the things you get better at with practice, of course, but oh, Haskell. Oh, Haskell's punctuation heavy. I think punctuation heavy languages are really hard to read, but you can always get used to it. It's just a matter of reps. Haskell and Rust, both fighting for most possible punctuation. Anyway, let's take a break, grab some coffee, and when we come back, we'll check out some classes and objects and talk a little bit about how those work. That all sounds good? Everybody ready for coffee? All right. You guys are cracking me up. See you soon. 2, 1, 0. All right. Welcome back, everybody. Oh, there's a Slido link that I totally forgot to check. Let me get to that really fast. One question in there. Am I teaching algorithms or will it be Brian Doyle? Let me look at the schedule. Algorithms looks like it is, let's see, March, April. Let me look at the right cohort. Brady. Brady is algorithms. All right, everybody can hear me, right? I'm back. All right. Okay, are we ready to do some Python object-oriented programming? This is what's next. Classes and stuff. Let's get it. All right. That's the attitude I like. Remember, growth mindset. You go up against a problem, doesn't make any sense at first, that's okay. You go up against it again, and then you go up against it again and again until it makes sense. And you just do this until you learn the problem into submission. I should point out along those lines, there's a book I have called Intro to Algorithms, which I love, by a dude named Corman and some other people. This book is on the edge of what I find easy to read. No, that's not true. This is the edge of what I find difficult to read. And there are sentences in that book where I'll read the sentence and I'll get to the end of it and I'll be like, no, I don't get it. I just didn't get it. So I go back and I read the sentence again. Sometimes I have to read those sentences like 5 times. Like, what are you saying here? What are you saying? And so one of the attributes of a good developer is just that pure tenacity. To be like, I see there's a problem here. I don't get it. And I'm going to keep hammering at it until I do get it. I'm going to keep asking my questions. I'm going to keep trying to learn this stuff. And even if it didn't make sense the first 20 times, I'm going to try it again and see if I can make it make sense this time. And certainly not all those books are created equal. I have algorithms books that I read, and I'm just like, man, this isn't doing it for me. There is a book called Grokking Algorithms. I'll drop a link to that for later. If you want to preview it, we do have like a 30% off coupon code or something for that for Lambda students. That's my favorite beginner's algorithms book. In fact, one of my favorite algorithms books ever, Grokking Algorithms. All right, let's do some object-oriented programming. Oh, let me get my notes out here. I'm going to start with something simple, and then we're going to do something slightly more complicated. So first of all, I just want to look at the syntax. The book was Grokking Algorithms, and like I said, I can give you a link to it, and a coupon code. I just need to look it up. The verb to grok means to understand very deeply and completely. If you haven't run across it before, it's from a science fiction book called Stranger in a Strange Land. And programmers use the term to mean like you have achieved greater understanding of a topic. All right, so I'm going to define a class here that does some things. And we'll just use this to get used to the syntax. And then later we'll come back and do a real example. And I'll throw all this down. If it doesn't make sense at first, that's okay. We'll come back and revisit some of this stuff. All right. So here is the simplest class I can think of. I call this animal, could be called anything. But what I'm doing here is I'm saying this is a type of object that represents an animal. And you can think of this as sort of the blueprint for an animal. It's not an animal, it's the blueprint for one. So we don't have any animals yet, we just have a blueprint. I would use the word template there, but template has other meanings in other languages, so I don't want to use it. Line 2 is the word pass. Pass in Python does nothing. It's just an instruction that does nothing. Like if I run Python, if I can type Python, it's like, sure, okay, you told me to do nothing, so I'm doing nothing. Syntactically, when you declare something that has a colon at the end, you need a block after that. There needs to be something down here. And so by saying class animal pass, I'm saying define a class. Remember the blueprint for an animal, but right now it doesn't have anything in it. It's just sort of an empty blueprint. And it's really uncommon to see this code right here. I just have it here right now so that we can run it. Otherwise the program won't run. We'll replace the word pass with some actual stuff in just a minute. It's just there as a placeholder. So I said earlier that this is just a blueprint for an animal. We don't have any animals yet, but we could make some. Just like this. So this is the syntax to look for. I've got the class name. I've got some parentheses afterwards. This means make me a new one. Take that blueprint and make an actual animal out of it. And this is called an object. Comment that out. So cat and dog are objects. Animal is the class. Coming from another language, you might think on lines 4 and 5, something is missing. Do other languages do something slightly different here? There's no new keyword. Lots of other languages have the word new here. Like, hey, cat is a new animal. Make me a new animal. New is not a thing in Python. It's just not there. Python says, hey, animal's a class. So clearly you're trying to make a new one. So Python decided new was redundant, left it out. Colin says these are instances of the animal class. And they are instances of it. There's so much terminology in object-oriented programming that you have to get used to. So one of the things we can say is that cat is English. Been practicing English for this many decades and still. Cat is an animal, or is an instance of an animal. You might also say that just cat is an animal. I mean, that's just true, right? That's true in English or here in Python. And in fact, for this, we say that cat has and is a relationship with animal. This is just a long-winded way of saying cat is an animal. We'll get to this is a relationship. Actually, I'm misspeaking a little bit. I'm going to hold back on that. Forget I said that. Just rewind that part. We'll edit it out in post. All right. Cat doesn't have much to it right now because the animal blueprint doesn't define anything. So let's define some stuff. Earlier I said that we're constructing a new animal. This is the actual terminology. Which is kind of weird, but it'll make more sense in a second, because there's a function called the constructor that helps initialize the animal. So right now the animal's not getting initialized to anything, but maybe we could have a constructor, which is a function, to put something in there to give that animal some attributes. Like, for instance, leg count. Animals have different numbers of legs. So I'm going to put a constructor function here. This is the constructor that gets called when the animal is constructed. And this is what the constructor looks like. And I'm going to give the animal 4 legs. I'll give all animals 4 legs. What is going on here? What is with this crazy looking syntax? Now, if you want my opinion, this was the ugliest design decision that Python made. This one right here. Using double underscores around the name of the constructor. The constructor is named underscore underscore init underscore underscore. Or if you want to shorten that in English, you might say dunder init. Dunder for double underscores. So the constructor is always called init with double underscores. Whenever you see init with double underscores, you're like, I'm looking at a constructor. I'm looking at the function that gets called when a new object gets created from this blueprint. So when I create a new cat, it calls this function right here. In fact, we can print it out just to make sure it happens. So when I run this line of code, we should print out constructor called, and this line will execute. When I run this line of code, it'll print out constructor called, and this line will execute. Now, self, Katie says, self is like this in JavaScript. You're totally getting ahead of me, but yes, I was going to say that next. You've headed it off at the pass. Self is like this. But even that concept, this as a concept, or self in this case, they mean the same thing if you're coming from JavaScript world. And Swift, does Swift use this or something like that? I think Swift uses this. It would, right? Self, really? Wow. They broke with decades of tradition. All right. So the concept of what this is the object that's being created right now. So when I run this line of code, line 7, we're creating a new object, and we're going to have cat refer to that object. So we're making ourselves a new cat here. That cat, as it's coming into existence, as it's being created, or also more terminology, instantiate animal. Constructing an animal, we also call that instantiating, making an instance of. So when this animal is being created here, it has to exist in some form. It just exists in this uninitialized state at first, and then we want to initialize it. So self refers to this animal that we're making right now. Self is this, yeah. Self is just like this in JavaScript, which is just like this in C++. And so as we make this cat from line 7, we're going to call for the cat, we're going to call this, and we're going to print this out. And for the cat, we're going to set its leg count to 4. Another way of thinking of self is it refers to the object that this method is working on. And by method, I mean a function here within the object. So there is an object and we're using it right now or doing something with it right now. And self refers to that object. If you want to research more about self, you can look at any book about Buddhism. Jason, I think that's a valid argument. I don't have a good comeback for that. It does keep the namespace clean, and it's something I hadn't thought of. All right, let's give this thing a run just to see what happens. Wow, am I still editing day one? So we can call it day one the whole time. Oh well. So I ran this and it said constructor was called 2 times, which makes sense because we instantiated 2 different animals. So makes sense that for each one of them, its constructor would get called so that we'd initialize the cat and the dog with a leg count. Now let's print that out. A little more syntax here. All right. Well, thank goodness, because otherwise the cat would have been having a bad day. But check out the syntax we just used right here. That dot syntax. Coming from JavaScript, that should be super familiar, right? Unless JavaScript's changed a lot in the last year or 2 since I've looked at it. So in Python, we say that the objects themselves have attributes, and we get at those attributes with dot. So the cat has a leg count attribute. And that attribute is a variable that refers to something. In this case, refers to the number 4. Moses, this is a great question. So classes produce objects, not dictionaries. That's correct. For now, you can think of dictionaries as its own beast. If you want to tie it in, a dictionary actually is an object. It's just an object with special abilities. But objects are more general. So when you make an object like this, there's no dictionary involved. This animal, there's no dictionary. And that's a little different than JavaScript, right? Where the object itself, syntactically, the object in JavaScript looks like a dictionary in Python. So this is where your brain's going to have to shift a little bit. Dictionaries are like, yeah, they're like super objects. Yeah, I guess you could think of them that way. But I would also say that they're just objects that have special attributes and properties to them. And in fact, with a dictionary, you can still use dot to do things because they're objects and they have methods on them. It's just if you want to access a thing in a dictionary, you just can't use dot for accessing the thing in the dictionary. That's all. You have to use the bracket notation to make that happen. Is the only way to create an object by initializing it with a class? As far as I know, yes, with the possible exception of the built-in object. That's like a base class object, but more about that tomorrow. Extremely, yes. Practically, Brian, the answer is yes. Somebody else may have defined that class for you someplace else. Like there are some built-in classes like with the calendar code, if you were working with that, there's some built-in stuff. But somebody, even when you're using the built-in stuff, somebody has defined that class for you somewhere. No, man, Jason, I don't know if I'm gonna be able to answer. I'm gonna get everything right with the. Let's see, Jason, I would say JS objects are like class instances. Yes. Yeah, I guess I think I would agree with that. David said you were under the impression that dictionaries were lighter objects. They are heavier objects. We could actually, this might be a fun exercise someday as extra material. We could make our own version of dictionaries in Python. Like we could start with a class and call it like my dictionary, and not even inherit from the built-in dictionary. We just build a dictionary from scratch with that kind of access. So that might be a fun exercise someday. Yes. I understand that dictionaries are objects, but they are also considered a data type in Python. Yeah. So let me, they are, and they're built in, and they're written in C ultimately, so they can be super fast because people use them so much. But here, let me throw my class animal in the REPL here. So just make an empty class animal. So it's telling me animal is a type. Let me make myself a new animal here and see what the type of the cat is. So animal itself is a type, it's telling me. But then if I make a cat out of it, it's telling me that the cat is a class animal. You can ignore the main part for now. But dictionary is built in. And so Python's smart enough to tell you that that's a dictionary. So even though it does act like a class that does specialized things for dictionary lookups in order one time, more on that later, even though it looks like that, Python's a little extra aware of it. So when they designed the language, they're like, this is so important that we're going to build this in at a really deep level. It's going to act like an object with these special things, but we're going to build it in at this deep level. The language is going to be aware of it at a very deep level, and it'll be permanently available to everyone. Let's see here. Is everything a class in Python like everything is object in JavaScript? No. No, everything's a type, and some types are objects. There's like a type associated with every kind of data, and some of those types are objects, just like we saw here, where I said ask what the type of cat was, and it told me it was an animal, which is a class. So, man, is everything a class? I'm gonna answer that wrong. I'm gonna have to punt, Brandy, because I think the answer is no, but I haven't researched it enough. I want to write it down though. All right, it's on the whiteboard. I mean, they all have types deep down, but is it? I don't know how. Well, it does say it's class. It does say it right here, right? So, but is this class? Is this meaning like class, or is that meaning like classification class? And they're speaking loosely, which would be unfortunate. I'm not sure. But I'll look and find out and learn something today. Any day you learn something new is good. And Katie, I'll come back to that question later. Maybe when we get to computer architecture, which is at the far end of the program. It compiles to C isn't quite right. It compiles to an intermediate bytecode that gets interpreted by a program that's written in C. But don't worry about that at all. We'll understand more about how it works when we get to architecture. Can we extend or override the built-in types? Yes. You can inherit from the built-in types, but I'm going to talk about inheritance tomorrow. Okay, one last thing I want to do here is that we can mutate these things, or I shouldn't say mutate, we can reassign them. So if the cat has some kind of accident, we can change it just like you can in other languages. And then we see that change is reflected in the object. Of course, just because we changed the cat doesn't mean the dog changed at all. The dog still got constructed with 4 legs, did not have an accident, and so the dog's leg count is going to be 4. So that'll be fine. I feel guilty. We can rebuild him. We have the technology. There we go. Now the cat's back to normal. Yeah, what if one cat lost a leg? So we could have a whole bunch of cats. We could even have an array of them. How about rabbits? There are always a lot of rabbits, right? Let's make a list of rabbits. And I'm going to split this up in multiple lines here just for readability. And what are we doing right here? Messed up my comment. There we go. So here I've made a list of rabbits. And in that list, I'm constructing new animal objects. So these lines of code get executed as the list gets built, right? And so this will make a new animal, put it in the 0th entry in the list. This will make a new animal, put it in the 1th entry in the list. And this will make a new animal and put it in the 2th entry in the list. So we've got 3 of them. They all have 4 legs. But got a lot of output here. Let's get rid of this. So rabbits 0's leg count is that. But we can modify one of them. So this will modify it for rabbit number 1, but the other ones should be the same. A lot of constructors being called here for cat, dog, and all the rabbits. We see that rabbit 1's leg count, sure enough, has been modified, but the other rabbits are not changed. Good find, Tony. That looks like almost everything. Jason, totally. List comprehension. Make 3 rabbits. That would absolutely work. No, it should be called every time. Patrick, you're getting on to the next thing I want to talk about. But yeah, what about this? What about this constructor thing? We're not really using it very well because we have this hard coded in here. Every animal has 4 legs. Sure, we can change it later, but wouldn't it be more convenient, especially if we've got a bunch of centipedes? I mean, And then we have to manually go in here, change it every time we make a new centipede. That's verbose and irksome. So we can pass that thing into the constructor. Why don't we put it in there as an argument? So we can make an animal with 4 legs or an animal with 100 legs. We can put this as an argument right here. And this is a really common pattern. You might think that these 2 leg counts are the same, but they are not. One of these leg counts, the one that I have the cursor on, refers to this parameter right here, leg count. Whereas the other leg count, because it has a self dot in front of it, it's talking about the attribute on this object. So I've just unhard coded that leg count. And now we can create animals with a certain number of legs right off the bat. And that doesn't mean you can't have other things in here that are hard coded. Like you can hard code stuff that's really common to animals. Or maybe an animal needs an array associated with it or a list associated with it to store something, who knows what. You can initialize a list there. And so constructors usually have a blend of hard-coded and passed-in things. And when you build a class, you're thinking about the programmer who's going to use it. You're like, what's the programmer who's going to use it? Who might be you? What's the programmer who's going to use it going to need to pass into this thing to make their lives easy? And so you add those things as arguments, parameters. Tony, there probably is. I'll bet you there's an attributes dictionary somewhere, but I don't know off the top of my head. A lot of those double underscore things in objects in Python give you a lot of power to do that kind of stuff. The init is the initializer. Yes, the init function is the constructor. This is, and initializer is another great word for it. This is what initializes the object. And we're programming, so nothing is obvious. All right, Dylan found the under the hood stuff. All right, there's one more thing I want to show you on this front. There's also default values that you can give these things. So by putting =4 up here next to the parameter, that makes this an optional argument. So now I don't have to specify 4. I could if I wanted, doesn't hurt anything. But if I don't specify anything, then leg count defaults to 4. This is also a really common pattern. And this makes the programmer's life easier because the common case, animals with 4 legs, is taken care of for us. But if we want the animal to have a different number of legs, no problem. We just throw that in. Let's see, Cody. When we use super on class and instantiate it, we can assign it the attributes it inherits in the exact same way we're doing here. We use super on class. I'm not sure I'm following the question exactly. Have you messed with super already in Python? Because super in Python's a little weird. But if the question is more of if you inherit from another class, can you use the attributes Yes. It was in the assignment. Great. Shows what I know. So super, let's talk about super tomorrow. We'll get into it in more detail, but it basically returns the class that is the parent class for this object, and then you can call methods on it. So it doesn't necessarily return any kind of object. It just returns the parent class, and then you go from there. Ethan will talk about subclassing tomorrow. It is, Ariana, it's definitely similar to super in JavaScript. It's just a little funky, that's all. Kind of works the same way, and then sometimes kind of doesn't, depending on how you use it. Oh, Omari. Leg count equals 4 versus leg count equals 4 with spacing. This is weird. I've never thought about it before because I always use spacing in the main body of the code. But for some reason, I don't put spaces around this. I don't know. I'm gonna have to look that up. But if you want to check it out, it's probably specified in a document called PEP8 that you can Google for, which describes how you should do this kind of code. From the compiler standpoint, it doesn't matter, or from the language standpoint, it's not going to care. I just don't know which one is actually the recommended style. And I feel like it's no spaces here for some reason. Which is inconsistent and weird, but I don't know. Okay. So we've talked about the constructor initializes the new object. We've talked about constructing a new animal, which is the same as instantiating a new animal. The new animal is an object, like cat and dogs are objects, but also these are called instances. Just more terminology for you. Let's see, leg count is an attribute on the object. Object. Methods. Let's see here. It seems like we only define attributes. Let's see here. Kumar, it seems like we only define attributes in constructor class. Is there anything else we can do? I'm going to stop here. And I say again, all these questions have been excellent. I really appreciate it. Every single one of them. This is great. The only thing we do is define attributes in the constructor class. I would say that's the most common thing that happens. So the constructor typically sets up a bunch of attributes, and that's about it. Other things like printing things out, a lot less common. Almost all my constructors look very similar to what we have here on the animal. First of all, I'm going to say probably, because I don't know Swift. But since the constructor is doing initialization, I would say yes. If I had to bet all my money, I would say yes. But I really don't want to bet all my money. Okay. One more thing I want to do here is, well, actually, there are two more things I want to do here. No, maybe three. I'm going to write a new method here. And remember, method is just another name for function, except specifically a function that is inside a class, a function that operates on these things. So I'm going to write something called getLegCount. And the first argument to any method, like getLegCount or init, the first argument is always self. If you get, pay attention to this part because it's going to happen. If you get an error when you call a method on an object and that error says incorrect number of arguments, very likely you have left self off the list. So if you get the error that says incorrect number of arguments, first thing to check, did I put self in as the first argument? Remember that, because that'll come around. This is something we'd call a getter. And we can use that to get a leg count from an animal. It's a function, a method, so you use parentheses to call it. And that should get us the cat's leg count, or 4 at the very end of the day. So you can add as many of these methods as you want. The trick is these should have something to do with the object itself that you're talking about. So right now we have something that's very specific. It's an animal. It does one thing. It's just an animal. That's it. It has attributes about animals. It has methods that have to do with this animal. I'll write a setter here. Let's call it leg count again. So here I've defined yet another method. Although it looks like it takes 2 arguments, really we're just passing the one in, the leg count. The self is implied. And so I could use this to set the leg count of the cat. Then we could do the same thing again here. Now, you might be wondering, like, why am I doing this? Why am I doing getting and setting when I could just use cat.legCount? Samira has it. Facilitate encapsulation, a word we'll talk more about tomorrow. But if a programmer that comes in to start using your classes, they're just using getLegCount and setLegCount. They don't have to think about how leg count is implemented under the hood. Right now, we have it implemented as an integer, but what if we decided to go crazy and implement leg count as some kind of object with lists and a dictionary for whatever reason? The user of your code doesn't have to know. They're just going to call get leg count and set leg count. And whatever those functions have to do, they can just do them. It's a black box from the outside. So that's a convenient way to hide the data. So it's pretty common to have these. If you want to use them for the stuff we're doing this week, go for it. If you don't, it's okay too. Oh. David's got a case question. What about camel case versus the underscores? So this is either of those types of function names are valid in JavaScript and in Python. The variable names. They can be uppercase, lowercase, underscores, non-underscores. It's really a convention, and it kind of varies from language to language. Python's decided to use underscores. JavaScript kind of likes the camel case. C likes underscores. C++ likes camel case. They just decided, and that's it. And Lisp uses hyphens. So stick with whatever the common spec says. If people are doing it commonly, if you go to a shop and you're writing Python and the shop already has a bunch of camel case in there, like keep using camel case, even though that's not typical in Python. If the shop has a style guide that says use camel case, use it. If it says use snake case, use that. All right. Let's take a break because it's been a while. And everybody can coffee up. And when we come back, I want to code a little bit of we'll make a store that has products within the store and categories of products, like departments within the store, and see how to construct or how to design these classes based on the English description of what we have. So we'll do that when we come back. Any last minute questions here before taking another break? Two Slido questions. Man, I'm so not in the habit. Thank you. Thank you for the reminder. Let's see. Main animal is a reference to if name is equal to main. Yes, that is what that is a reference to. So we haven't talked about this in great detail yet, although we will. The main is the name of the module. When we have different modules, it'll describe what module the animal or what module the class is defined in. In this case, we're doing everything in one file. It's the underscore main file. And so it'll change based on which module you import it from. And the other question, this is from a while back, so I think we addressed it. Leg count does not need to be passed in the instructor into the constructor like self. No, it doesn't. It doesn't need to be passed in. Just like here, likes food, I didn't pass it in. But it can be passed in if that makes it easier for us to use the class later. So. All right, let's do this break and jump into some more OOP stuff here at the end. And I think right in the last couple minutes of class, we'll do a couple things about modules, just because the assignment today and tomorrow does some stuff with modules, and I don't want it to be too spooky when you see it. But that'll come next. Now let's get up and stretch and relax your brains for the next part. See you all soon. All right, I'm back. Everybody coffeeed up? Get your break? Thumbs up. All right. Okay. For this, all right, I'm glad the 7-minute breaks are good. For this next bit, let's do, let me get my thing here. All right, we're going to implement a store. And I'm going to put this inside a multi-line quote to demonstrate a thing here. So we're going to implement a store to hold information about products. And so I'm going to write some stuff down. A store can have multiple departments within the store. Men's clothing, sporting goods, etc. And this can hold multiple products. Let's see. Store has a name. Products, departments have names. And products, we'll say, have names and prices. All right. So I've got this description here of what we want. First of all, are we good with this description? Just as concept of the store. I can't tell where all the thumbs up have come from. It was everybody being happy before. Okay. Yeah, all right. So now my challenge to everybody is, how can we turn this into classes and attributes? How can we take this English description and turn this into exactly what we need? Ooper solves everything. So I have a bunch of little rules here that I use. And by rules, I mean guidelines. Before I continue, this is legitimate Python right here. This is a multi-line string. So you can have a string that takes multiple lines. You start it with 3 quotes, end it with 3 quotes. And if you have one of these on its own, Python ignores it as a comment. So I'm not doing anything. I'm just like throwing a string out here in the middle of nowhere. Python's like, oh, that's a comment, multi-line comment. So you might see this going through. And in fact, we'll use it in a second when we define our objects. Yeah. So the rules that I tend to think of when I'm looking at this stuff is that nouns tend to be classes. So not all the nouns are classes, but the big nouns are classes. And if something has something else, I shouldn't say this. If a noun has something, that something tends to be an attribute on the class. And yes, I'm going to totally mispronounce it. Adioi. Am I getting your name right at all? Adioi. Oh. Adioe says verbs are methods. Yeah, verbs tend to be methods. Tend to be. But of course, not all nouns are classes. Not all things that a noun has are attributes. Not all verbs are methods, but they tend to be. So when you're reading the English description, look out for these things. So yeah, Aaron's looking at this stuff now and thinking, all right, well, the nouns tend to be classes. We've got some big nouns here. We've got stores, we've got departments, we've got products, we've got names, but I'm looking at this, I'm like, well, actually the store has a name. So instead of making name a class, name's probably going to be an attribute on that class. So we can make some classes here. And again, I'm going to put pass just as a placeholder. So if we have valid Python, we can fill out the class later. So we're taking our English prose here and we're translating it into code. What about the attributes? What things can have things here? Ooh, Spencer's like, done. Let me produce for you the definitive documentation for where this is going. Excellent. Aaron cracking me up. Oh, this is all good stuff. Oh, so yeah, we've got a lot of things that have things here. Like, let's start off with one of the easy ones. The store has a name. All right, so in the store, we're going to put a constructor here. And I'm just going to leave it with no arguments for now. Actually, I can't do that, can I? Let's put it in there. The store has a name. All right, great. Made a constructor. We can pass a name in for the store, and that's taking care of this bit of the description right here. The store has a name. It also says departments have names and products have names and prices. So I'm just going to throw all those in right now as well. I'm just going to copy that code and paste it down there. And I said products could have names and prices. So let's throw that in. All right. So what do we got here? We identified our big nouns, store, department, and product. And we saw that stores can have names, departments can have names, products can have names and prices. And we've added constructors to initialize all this stuff. Stores got names, departments have names, products have names and prices. All right, well, that's a lot of it. But we left out a couple big things here. What else do we need? Or more questions? Can a department inherit its name from the store? I'm going to stay away from that question a little bit because we'll talk more about inheritance tomorrow. But you're getting into something that is a versus has a relationship. We're saying here that a store has departments, but we're not saying that a department is a store. Those are kind of different ways of thinking about this. Or we're not saying a product is a department. So in that way, we probably should not inherit that name. But tomorrow when we talk about inheritance, we can look at that in more detail. Now let's see, Heather, self-departments equals empty and an it for the store. I like this. It's the fact that we can have multiple departments makes things a little interesting. We only have a single name, and so a single name for a store, no problem. But a store can have multiple departments. If a store can have a thing, that means that thing should be an attribute. Because remember, if a noun has something, that something tends to be an attribute. A store has departments, so I'm going to put that in there. But since it can have multiple departments, not just one, we need some kind of collection to hold all those departments. So sure, let's initialize this to an empty list. So now we've constructed a store that has a name and it has a departments list, but it doesn't have any departments associated with it. So when we construct a new store, we'll end up with a store with a name but no departments. But that's okay, because we can always add departments to it later. And Mauricio and Greg, we're going to stay away from child classes and parent classes and super until tomorrow. The question is, what departments does a store have? We'll get to that in a little bit. Right now, we're just laying out the blueprints. But after we get the blueprints laid out, we'll instantiate a store. We'll create a store, and we'll instantiate some departments and some products. And we'll put all those products in a department. And we'll put all those departments in a store, because the store has those departments. And then we'll have that data in there. So we're still at the blueprint phase now, but we will get to the data phase in a little bit. And the departments need to be connected to the store. Should we indicate which department the store belongs to as department attribute? Let's see, department attribute, or hold it as in the directions within, or hold it as is in the directions within store as many departments. I'm not sure I'm understanding that one quite right. But haven't answered it yet based on what we've talked about. And Heather's like, oh yeah, we can add some, you could add some accessors there, add department. We totally can. But we also need what? We said a store can have multiple departments, department can hold multiple products. So let's put that in here too. Give room for the department to hold multiple products. Jason's got some code there. And you don't know it yet, Jason, but there's a trap. There's a trap in Python that you've just stumbled into that I was hoping to avoid talking about. And there's a pattern. There's a pattern for that kind of initialization that I'm going to show you. This seems like it should work in Python. Yes, I agree. That makes total sense. And it does kind of appear to work for a little while before it breaks in the most confusing way. And I don't have time to talk about this in detail now, but I can post something afterwards that describes it. Whiteboard note to myself to do so. There's a pattern here, and this is the pattern you should follow. And you're like, why? Why am I doing that instead of just initializing it up here like this? Why am I doing all that stuff? There's a reason for it. So use that pattern if you want to do this kind of initializer. It's only for, I'm going to say it's only for lists. That might be wrong. It's only commonly used, this pattern's only commonly used for lists. Otherwise, go ahead and use equals up here in the initializer, just like you'd think it would work. And Python behaves differently than JavaScript in this case. It's a little weird. I'll post something about it later. Ethan is, yeah, what Ethan said. It's really funky. Anyway, all right, so I think we've got this here. I've got a couple little misc things to talk about. One is, I said this was a comment up here, and it is. It'll be ignored. You can also put comments in here, whether there's a single line or multiple lines. Typically, these comments start with 3 and end with 3 quotes, no matter what. This is a documentation string. So if you have a documentation generator, it'll look for this string right after the class. This defines what the class does. It's a really common way of commenting these things. And you can put them inside methods like this as well. You'll see these kind of documentation strings in code. So I wanted to point that out. They're just comments, but when they appear right after the first line of a class or right after the first line of a method or a function, then they get included in documentation if you use an automatic documentation generator. So that's one thing I want to point out. Another thing that we didn't do yet is actually build anything. So I could build some products here. I almost typed the word new there, wrong language. Let's make this a number. How about, do soccer balls cost $12.99? They probably don't. They probably cost like $42.99 for the cheap ones. So I can make new products like this, and then I could make a new department. And then we could add that. So here, I'm kind of chaining all this stuff together. We've written the templates, we've written the blueprints up here for store, department, and product. Whoa, don't hit the wrong key. That's a little better, all right? We've written the blueprints for store, department, and product, but here we're actually instantiating things. We're making things. So at this point, there were no soccer balls, but here I'm like, hey, let's make a soccer ball. Now we have a soccer ball, and there are no departments yet. So I'm like, let's make a department. Let's do the department right here. And of course, the soccer ball and the sporting goods department aren't connected until we actually do connect it. Where I'm like, okay, let's take the products list that is inside the department right here, and let's append the soccer ball onto it. And Samantha says, shouldn't we use a method instead of a pen? Shouldn't we have a method here like add product, sell product, and then in here do the hard work? Sorry, my screen just froze. Give it a second. Give it a second. It's restarting. All right, it's back. Can't we just do this? Self.products, DUCTS, append product. Let's put it in here. This would clean it up a little bit because as a user, this is kind of ugly. This line 41 I have, it would be a lot nicer if instead of doing that, I said sporting goods, add product. So yeah, Samantha, that is much nicer looking and easier to use in the future. Like right now, my products are a list. What if I decided to change it to some kind of dictionary? That would break line 41, but it would not break line 42. So definitely better. Well, I know how to push this right to the very end, don't I? Of course, I have like 3 minutes worth of stuff to talk about still. I will post all this code to the Notepad channel. We're all in. All right. So that was kind of a whirlwind description, but go ahead and let your brain chew on this. What we did here with the description of the thing, how we took nouns, verbs, and has to put these together. Tomorrow we'll talk about inheritance and is relationships as opposed to has relationships. But here we have a store that has departments, department that has products, products and stores and departments all have names. And here we are constructing the store, the actual store, based on those blueprints. Notepad channel. Oh, yes. Everybody should join the Notepad channel. This is where I post code, links, videos, anything that would normally get lost in the shuffle of the main channel. I throw it in Notepad for easy reference. All right, let's look at the thing. The thing. I'm very exact. Let's look at the thing. Today we're going to do the thing with the stuff. This is the next 2 days. Another 2-day repo, Intro to Python 2. And in it, we're doing an adventure game. A simple adventure game. But this is broken down, day 1 MVP, day 2 MVP. Remember, in Ooper, understanding the problem means going through this stuff first and making sure it makes sense. And if there's something in here that doesn't make sense to you, either because the specification is wrong, we try to make sure it's not wrong, but we're only human. Occasionally people find mistakes, either because the specification is wrong or because the specification is incomplete or something is just unclear for any reason at all. Please don't hesitate to ask to get clarification on what it is you need to do here. But the MVP is kind of spelled out. But the MVP doesn't go like step by step. It just tells you, hey, look in this file and do this thing. Now down here, there's a lot more information about what to do. But basically, we're going to do a text adventure game where there are rooms and you say like west to go west or east to go east. And you walk from room to room and pick things up and drop things and stuff like that. So check out all this stuff. There are a lot of stretch goals here. I mean, the basic adventure game is pretty basic. You could add all kinds of things to it if you wanted. If you don't like adventure games, try to think of this as a chat room instead, because some of the same ideas, like Slack, some of the same ideas actually apply. Like an adventure game, you walk through and you pick stuff up and drop stuff and like say things. If it was multiplayer, you talk to people. That's the same thing that happens in Slack, right? You go from channel to channel and you do things and talk to people. So I happen to like adventure games. I know I'm not alone in this. Some people don't like them. If you don't like them, pretend it's a different thing and know that a lot of the same ideas hold. Now in here, part of understanding the problem is going and looking to see what's in here. And some of you may notice as you're panning down through these, what, a FAQ? There's a FAQ in here, probably some good stuff in there. Remember how I said when I went to Activision, they gave me a week to figure out the source code so I'd know what to change? This is practice for that. There's some source code in here already. So figure out what this stuff is. And the last thing that I didn't get to during lecture that I really wanted to talk about, and I'm only going to skim now, but please ask me about it if it's unclear, is how these multiple files come together and work. When you run the program, you're going to run adv.py. So on the command line, you'd be like Python adv.py. It'll run this program right here. And this has some stuff in it, like we're building a dictionary, we're constructing some room objects. You'll have to look through this and see how it works. That's part of the challenge today, is to look at this existing code, figure out what's going on in the existing code. Again, ask a lot of questions. This line right here is important. This is talking about modules right here. And what this is saying is from room.py, there's a file called room.py, it's already there. Go in there and bring in this thing, whatever this is, a room. In this case, I know it's a class. But this is saying, go into the room.py file and get room out of there so that we can use it in our code. So this is how the files get tied together. The main ADV file that we're looking at now is going to bring in information from the room.py file so that it can be used in the ADV file. Does that make sense? I mean, this should be very similar to imports or includes or something in the previous language you have. Bring something from another file into this one so that I can make use of it. You do not need exports. Good question. So you don't need it to explicitly export things. Yeah, like required, exactly. And so you've noticed there were two files here, player and room. Player also pretty bare right now. It says write a class to hold player information and so on. You're probably going to want to import that player information into the main file here. Also, one more hint at the bottom of this main file, it talks about what you should actually write. So remember, understanding the problem. I'm going to lie and say I never skimp on this. Of course I do, because I'm tempted. But really, what you should do before you start anything is go through and inventory everything you've got in this repo. It's not that big. I know it's got a couple directories, but look at everything that's in here and be like, what is important? What do I need to know? And what can just wait till later? That initial overview will help you figure out what to do, especially when there are things in here like a FAQ that probably has a lot of great stuff. Remember yesterday when I said I would not go 7 minutes over? I was totally right. I went 8 minutes over. Ugh, so bad. All right, any more last minute questions before we call it lunch? And I will be around. TLs will be around. Every time I go over, even by a few minutes, I'm always going back to the guided project, and I'm like, how do we have to restructure this to get this time down? Oh, what do I recommend for data persistence? It depends on how we want to persist the data, but I've got two recommendations. One, either just write it to your own file, like come up with a file format. Depends on what kind of data it is, but putting it in your own file always works. SQLite is a great SQL database that is easy to use. That's a great place to store things. Yeah, flat files. There is a serializing, what's it called? I think it's called struct, struct. Is that right? In Python, there's a built-in serializing module that you can use as well. But if you really want to have fun with SQL, check out SQLite. It's a super lightweight single user database that's ultra fast. As long as you only have one user, it's ultra fast. All right, gang. Let's do lunch. I had 2 notes. Yes. Okay. I'll add some additional information. And if there's anything else in Slido, I will answer that. There's a question about private fields. I'll answer that stuff in the Notepad channel. Thank you all so much for your time. Sorry about the technical difficulties at the beginning. Hopefully that's just Zoom working out the kinks. And I'll catch you all soon. See you all out there.